I want to eliminate the sine inverse, so I'm going to take the sine of both sides. Take the sine of both sides, it means that sine y is equal to sine of the sine inverse of 3x. So that when sine meets sine inverse, they cancel out. It means that sine y is equal to what? 3x. It will interest you to know that we need a mix of the quotient rule and the chain roots together to solve this derivative. Look at it. This is x over 1 plus x. That's already a quotient. But everything is raised to the power of 5. That makes it a function of a function. So inside the power function, which is raised to the power of 5, there is a function inside in terms of x, which is rational. The focus here is on differentiation, derivatives. So ensure you watch the video to the end and see how we're going to do a mix of the rules of derivatives in solving problems. The first question here is, we have to differentiate this function. We are asked to find the derivative of this particular function. What is the dy dx? Or what is the differential coefficient of y equal to x to the power of 5 plus 5x to the power of 4 minus 10x squared plus 6? Going by the rule of differentiation, all right, it's going to look like this. The dy dx of this function is equal to, let's differentiate term by term. Now, for the rule of differentiation, actually, if I have ax raised to power n, you do n times a, and that will be na. Then you write the x, subtract 1 from the n, which is the power. So I'm going to say, what is here is 1. So I'll be saying 5 times 1, that's 5. Then write the x, remove 1 from the power, that gives me 4. Come again, 4 times 5, that's 20. Write the x, remove 1 from the 4, that gives me 3, minus 2 times 10 is 20. Raised to 3 times x, 2 minus 1 is 1. Then if I differentiate a constant, a single value without a variable attached, it is 0. Yeah, the derivative is irrespective of the variable with respect to, you get it. So differentiate 6 with respect to x or whatever, it is always 0. So that's, it is out. So this is 20x raised to the power 1. I can remove the 1. You get it. But this is the answer, correct. But I can factor out 5. Actually, I can factor out 5x. So I'll get 5x into x cubed plus 20 divided by 5 is 4. That's 4x squared because 1x is outside. Then what's left here? 20x divided by 5x will give me 4. So this is also correct. The principle remains the same. Let's solve this second question. What's the derivative of this function? The dy dx remains this. 1 over 2 multiplies 3. Of course, 1 over 2 times 3 is going to be 3 over 2. Then write the x. Subtract 1 from the 1 over 2. That's 1 over 2 minus 1. And this is minus 3 over 2 multiplies the x. Then subtract 1 from it. And we have plus 2. 2 is here before. Multiplied by the minus 1 over 2. Then write the 1 over 2. Okay, write the x. And do minus 1 over 2 minus 1. Alright, so you must be very careful. So we have dy dx equals 3 over 2 times x to the power of half minus 1 is minus half. X, okay. What's 3 over 2 minus 1? It's going to give you 1 over 2 actually. Yeah, 2 times 1 is 2, 3 minus 2 is 1. So you're going to get 1 over 2, that's 1 half. Plus 2 cancels 2. Okay, plus times minus is a minus. I have minus x. Minus 1 over 2 minus 1 will give you minus 3 over 2. Yeah. Minus 1 over 2 minus 1 over 1. LCM is 2. 2 divided by 2 is 1 times minus 1 is minus 1. 2 divided by 1 is 2 times minus 1 is minus 2. Minus 1 minus 2 is minus 3. Alright, this is the answer. But most times in the exam, you will not see the options like this in the exam most times. So they will transform all these powers into square roots. See what I mean? By the law of indices, you know that a number raised to a fractional index will produce a root. You get me? So the a will be inside, raised to power x, this y will be outside, inside the square root. So what this means is this. But first of all, this power is negative. I will have to deal with negative powers first. Okay, same here. So see what happens. The divided x is equal to this 3 over 2. Since this one is negative, by the law of indices also, if I have a number that, let's say I have a raised to the power minus x, to eliminate the negative sign, I'm going to get 1 over a raised to the power x. So what this means is 3 all over 2 times the x raised to the power of 1 over 2 minus, we have 3 over 2, okay, x raised to the power 1 over 2. Then for this, to eliminate this minus, I'll take the inverse, 1 over x raised to the power 3 over 2. In the indices, based on what I showed you just now, the law of indices will allow me to write this as 3 all over 2. A power of 1 over 2 signifies the square root of x. Yes, minus 3 over 2. The same thing here, root x, minus 1 over 3. Okay, minus 1 over x. Now see, this is 3 over 2. It means that there will be a root. This 2 here determines the type of root, square root. Then the x will be raised to power 3. This will be divided x in, let me say, the simplest form. So you may not always see it like this in the exam. The examiner will most times leave the answer like this, and this is it basically. So let's differentiate this function now. 1 over 2x squared plus 4 all over root x. This is the trick. When differentiating functions that have rational powers, it's easy. We go straight into the normal principle. But when the question is like this, yes, when it's like this, like when the question now looks like the answer, what we do for the sake of, should I say, simplicity, we try to reverse the operation. I'll write this expression in the form without square root before I differentiate. That's the point. Okay, so get me now. You know what we did earlier, we saw that a raised to the power minus x is 1 over a raised to the power x. It's like a forward and backward reaction, a reversible reaction. So what this means is y equals 1 over 2 times x raised to the power minus 2. That's the meaning of this by law of indices. Now, the square root of x means x raised to the power 1 over 2. You agree? So if I should write this in this form, it's going to be like this: 4 times x raised to the power what? Minus 1 over 2. That's the meaning. That's the meaning. Alright, so this is it. From here I can differentiate. The y dx is this: 1 over 2 times minus 2, which is minus 2 times 1 over 2, times the x raised to the power minus 2 minus 1. Then I have my plus. This is minus 1 over 2. It's going to multiply the 4, multiplying the x raised to the power of minus 1 over 2, take away 1. So let's finish this now. You get it? You have to watch the video to the end and see the different questions that will be coming up in the video. Make sure you like, share this video to your friends and to your classmates as well. Alright, let's go down. Okay, so I'm here. 2 cancel 2, right? Okay, so minus times 1 is minus. So divide the x is negative x raised to negative 3. Then this is minus 1 over 2 times 4. It's actually 4 over 2, which will give me 2. So I have minus 2. You get it? Times the plus outside. It's going to be a minus. So I have minus 2 times x raised to what power? Minus half minus 1 is minus 3 over 2. Minus 3 over 2. Yeah, so what would this be finally? By the law of indices now, let's do this. This is minus 1 over x cubed. You get it? Minus 2. Because of this negative power, I'll write all over this cube. All over x to the power of 3 over 2. Positive 3 over 2 now. Okay, so let's finish this. Minus 1 over 3. Okay, minus 1 over x cubed. This 3 over 2 signifies a square root of x raised to the power of what? 3. And that is the derivative of this function. We have to find the derivative of this function. Now, look at it. This is y equals 2x in the square root. So we have 2x raised to the power 1 over 2. You know that. Plus 2 times x to the power of what? 1 over 2. Now, I think we have to perform something here. Yes, we have to perform the chain rule of differentiation. It's not, there is a coefficient attached, so we must do square root. You get it? Or I can say this is y equals 2 raised to the power 1 over 2 times x raised to the power what? 1 over 2. Yes, I can. Then this is 2 times x to the power of 1 over 2. So y is equal to the square root of 2 times x to the power of 1 half plus 2 times x to the power of 1 over 2. We can now find the derivative. What's the y dx? Root 2 is outside. Then this is 1 over 2. Going to multiply the x. Then we'll do 1 over 2 minus 1. Plus 2 is outside. Multiplying the 1 over 2. You know that. Then x raised to the power 1 over 2. Take away 1. So this is root 2 all over 2 times x to the power of half minus 1 is minus half. 2 cancel 2. So we have what there? X to the power of half minus 1 is minus half also. So what do we have now? I think I can simplify this. What's root 2 over 2? Root 2 over 2 is, root 2 is 2 raised to the power 1 over 2. All over 2, which is to the power of 1. So minus this. Half minus 1 is minus half. So dy dx equals 2 raised to the power minus half into x to the power of minus half. Yeah, x to the power of negative 1 half plus x to the power of negative 1 half. Okay, this is, you agree with me? If I do the indices, it will be 1 over 2 to the power of 1 over 2. They are the same. Then times this one also will be 1 over x raised to the power 1 over 2. Yes. Then this is 1 over x, the same thing. So we have okay, check. X, this and this, they are common. So these two terms. I can bring this one, everything here outside. 1 over root x. You agree with me now? Because x to the power of 1 over 2 is the square root of x, like we've seen earlier. What's left? This 1 over, this is still root 2 now. This is still root 2, yes. Then what's remaining here? 1. So we have 1 over root x into, let's simplify this. Root 2 times 1 is root 2. So we have 1 plus that root 2 all over root 2. I just did LCM in a simple way. So what will happen now finally? This multiplies this. This multiplies this. So this times this, 1 plus root 2. This times this is root 2x. This is the answer to the question. We are asked to differentiate y equals 1 minus 5x all to the 6th power. This question is on the chain rule. Yeah, there are two functions here. We have the power function and we have the inner function, which is algebraic. So what we'll do is we apply the chain rule to solve this particular question. Now, I will be doing a shortcut for the chain rule. The chain rule says dy dx is dy du times du dx. So this is the shortcut to the rule. Dy dx is straight, easy. What's here? 6. Write it down. Times what's inside this bracket? That's the inner function. 1 minus 5x, right? Differentiate it. Differentiate 1 to get 0. Differentiate minus 5s to get minus 5. Times it by that minus 5. See the first thing I did. The power, I wrote it down. Differentiated what was inside, wrote it down. Then rewrite this one again. 1 minus 5x raised to power 6, remove 1. Simple. That's the chain rule in application. I want to repeat the step once again. The power, write it down. The inner function, differentiate it, write it down. The original function, write it down, but subtract 1 from the power. 6 times minus 5 is minus 30. Then we have 1 minus 5x to the power of 5. So this is chain rule in 2 steps. If I use the formula, it's going to be up to 4 steps or 5 steps. Next question. Applying the same shortcuts. This question is also a chain rule question. Okay, by the way, let me tell you how to identify functions that are used chain rule to differentiate. We call it function of a function. Function of a function, or we say composite function. By composite, we mean that one function is made up or is composed of another function. See, raised to power 4 is a function, a power function. Do you get me? This is a function, a power function. 3x minus s cubed plus 1. 3x minus s cubed plus 1 itself is a function, algebraic. So inside this power function, there is a function, algebraic, meaning it is a function of a function. Functions like this, we use the chain rule to differentiate. I have sec squared 4x minus 1. This is a function of a function. Sec squared itself is trigonometric, right? Yeah, a trigonometric function. Inside the trigonometric function, we have an algebraic function 4x minus 1. So it means that there is a function inside another function that makes it a function of a function. That's it. So I can go on and give you more examples, but that is it basically. So the same principle applies to solve this particular question, number 6. The dy dx, in this case on the root f of x. Another notation for derivative is like this, f prime of x, which signifies the first derivative of this function. Then f double prime will signify what? Second derivative. So I can write this one like this, y prime of x. All right. The rule, write it 4 multiplied by the derivative of this one in brackets. Differentiate 3x to get 3. Differentiate minus s cubed to get minus 3x squared. Differentiate 1 to get what? 0. Then the process says rewrite this one again. 3x minus s cubed plus 1 raised to power 4 minus 1. That will be 3. Okay, I don't want to expand. This is already in the factored form. So let me just leave this one like this as 3. This is the answer in one step. Is that not interesting? That's the derivative of this function. So question 7, let's pursue. Stay tuned, keep watching, subscribe, like, and share the video to your friends and your classmates. Now, look at this function. Still chain rule function. Let's see. Dy dx, which is y prime of x, is write the half multiplied by differentiate this. This will give me 0, this will give me 4, this gives me minus 2x. That's the derivative. Then write this one again. 3 plus 4x minus x squared raised to power, check it out, This is half. The rule says subtract 1. What's half minus 1? It's going to give me minus 1 half. Okay, check. 2 is common. This is 1 over 2. I can factor 2 out. Remaining 2, remaining x. So that this cancels this into, check. Everything here is now raised to the power of what? Minus 1 over 2. If I turn it upside down, are you there? It's going to be like this. 1 all over 3 plus 4x minus x squared raised to power 1 half. So what's left? 2 minus x. Just follow me. I have 2 minus x times 1 all over this, which is the square root of 3 plus 4x minus x squared. Funny enough, everything here like this is exactly the initial function. Check it out. This is this. This is correct. Just take note. This is perfect. But what if the examiner tried to be funny? For example, this is 2 minus x all over 3 plus 4x minus x squared raised to power 1 over 2, which is also square root. It's exactly the function we have here. Everything under is what we have here. And this is equal to y. It means that I can write this as 2 minus x over y. And as a matter of fact, this is the way the answer is left in the question, where the question is coming from. All right, we are asked to find the derivative of this function. The function is theta, which is a function of arrow. Theta is equal to everything here in terms of arrow as the independent variable. So instead of saying dy dx, this time around it's going to be d theta d arrow. Yes, that's the meaning. But which rule of differentiation will work here? The rule of derivative that will work for this problem is the quotient rule. Yes, quotient rule says that dy ds, let me write it here. Dy ds is equal to v du ds minus u dv ds all over v squared. Quotient. This is what I said. Quotient rule. R-U-L-E rule. Alright, so instead of saying dy dx, I will now be saying d theta d arrow. But this is the rule in general. This is u. The top is always u. The bottom is always v. So the rule in general is this. It says write v times differentiate u with respect to x minus write u times differentiate v with respect to x divided by the square of v, as v squared. So let's go now. V is the one under 2 arrow plus 3. Write it. Then differentiate the one on top. Differentiate 3 arrow plus 2 with respect to arrow. Differentiate 3 arrow to get 3, 2 to get 0. So I'll be writing 3 minus, what's u? U is the one on top, which is 3 arrow plus 2. Then differentiate v with respect to arrow. That would be 2 arrow plus 3. Differentiate 2 arrow to get 2. You get it. 3 to get 0. So I'm writing my 2. Divide by the square of v. 2 arrow plus 3 raised to power 2. So anything I get from here is the answer. 3 times 2 arrow is 6 arrow. 3 times 3 is 9. 2 times 3 arrow is 6 arrow. In brackets, okay, because everything here is 1. And 2 times 2 is 4. All over 2 arrow plus 3 all squared. There will be no need to expand this one under. It's needless because we don't need the expansion. This is it. 6 arrow will take away 6 arrow because of the minus here. Then this is 9 minus 4, and that gives me 5 all over everything here. 2 arrow plus 3 all squared. That is the dy dx. Sorry, that's the theta d arrow of this particular function we have. Looking at the question, looking at this question at first, it looks like something you can solve easily, but it may shock you the way the solution will come out. Look at it very well. If I'm asked, what do you think, which rule do you think will solve this question? Is it chain rule? Is it quotient rule? Or could it be a mix of these two rules? By the way, can we use two rules to solve one question? Yes, it's possible to use more than one derivative rule for one question. Yeah, but let's see what happens in this particular question. It will interest you to know that we need a mix of the quotient rule and the chain roots together to solve this derivative. Look at it. This is x over 1 plus x. That's already a quotient. But everything is raised to the power of 5. That makes it a function of a function. So inside the power function, which is raised to the power of 5, there is a function inside in terms of x, which is rational. And we use the chain rule for such derivative of function of functions. You get it? So what happens here is this. I used the shortcut before, but I will not use it here so that it will look clear enough. Let the inner function be equal to u. That's the principle. I'm using chain. See, the solution to this question is chain rule, not quotient. But the point is that along the line, the quotient rule becomes necessary. That's it. So let it be equal to x over 1 plus x. You get it? Then I'll say differentiate u with respect to x. This is when the quotient rule comes in. Based on the quotient rule I wrote earlier, v du dx minus u dv dx all over v squared. Let's go. This is now our u. You get me? This is now v. So the original u remains for the chain rule, but this new u is for the quotient. Do this. Write this 1 plus s, differentiate this to get 1, minus write this 1, differentiate this. Differentiate 1 plus s, you're going to get 1. You know that? Yes. All over, write this 1, square it. So what would this be? This is 1 plus x times 1 plus s minus x, all over 1 plus s squared, which will produce 1 over 1 plus x squared because x minus x cancels out. So this is the UDS by the chain rule. So if they had asked me a question, differentiate y equal to x over 1 plus x only, this would have been my answer based on the quotient rule. But because of this power of 5, it turns into a chain rule question. So remember we're using the chain rule. Now, this is the principle for the chain rule. I have set u equal to this, the inner function. Then I differentiated u with respect to x. I got this. I will now say y is equal to, everything here is u raised to the power 5. What was inside the function? Set it as u. Of course, we said let u be equal to this. Then I'll differentiate y with respect to u. Differentiate this by the principle. 5 times 1, 5. Write u, then you do 5 minus 1, 4. So this is the y du, and this is the u dx. The rule says that the y dx for chain rule is the y du times the u dx. What's the y du now? 5 u to the power 4. 5 u to the 4th power. And what's the u dx? Everything here. Oh, sorry. I should have squared everything. Yes. So the UDS is 1 over 1 plus x all squared. 1 over 1 plus x all squared. So we have, this is u to the power of 4. What is u? U is x over 1 plus x. So let's replace it. X over 1 plus x raised to the power 4. You get it? Times 1 over 1 plus x all squared. Check it out. This is 5 times x raised to the power 4. This 4 here is affecting both the numerator and denominator. So we have 1 plus x all to the 4th power. The same thing you get times 1 over 1 plus x all squared. So this is 5. This is 5x raised to the power 4, all divided by, they are the same thing but they have different powers, so I can add their powers. 4 plus 2 is 6. So 1 plus x raised to the power 6. This becomes dy dx. Right, let's solve question 10. We are asked to differentiate this function, y equals 2x squared into the square root of 2 minus x. What type of a function is this? Looking at this function, it's a function that involves a product of two functions, 2x squared and the square root of 2 minus x. But the problem with this question is that we are not just going to use the product rule alone, but the chain rule will also be involved in the solution. Yes, check it out. For the square root of 2 minus x, I need the chain rule to solve that. Alright, and for everything in total, I need a product rule. So this function is a product rule question, but along the line, we are going to make use of the chain rule to solve for one of the functions. That's the derivative of one of the functions. So I will be saying, for product rule, take note. Product rule says dy dx is v du dx minus u plus u dv dx. This is product rule. V du dx plus u dv dx. This one, anyone can be u, anyone can be v. You get it? Unlike the quotient rule where the numerator is always u and the bottom is always v. So let u be 2x squared, which is the first function we have. If I differentiate 2x squared with respect to x, which is du dx, what will I get? I will get 4x. 2 times 2 is 4. Then 2 minus 1 is 1. So 4x. Alright. Now, v will be the other part of the function. The square root of 2 minus x. Before I will differentiate this function, I think I showed you earlier that the square root of 2 minus s is equal to 2 minus s raised to the power of 1 over 2. Yes. So, to differentiate this function, I'm going to make use of the chain rule. You get it? But I don't want to go through the hassle of using the chain rule formula or using the shortcut like I showed you earlier. So for dvds, using the chain rule principle now, I will say, what is the power? 1 over 2. Write it down. If you remember the shortcut I used earlier. The inner function 2 minus x, differentiate it. Differentiate 2 to get 0. Differentiate minus x, of course, with respect to x to get minus 1. Write it minus 1. Then write the function itself again, 2 minus x. Then subtract 1 from the power, 1 half minus 1. And that's the shortcut to the chain rule. So I'm going to say, this is 1 half times minus 1 is minus 1 half into 2 minus x. Half minus 1 is minus 1 over 2. So in the final application of the product rule, I will simplify this expression. So that the final dy dx is this v, which is everything here, the square root of 2 minus x times du dx. What's du dx? 4x plus u is what? 2x squared into everything here. Okay, let me bring this down because of space. Plus u is 2x squared. That's 2x squared into everything here, which is dv dx, minus 1 half into, okay, let me just write times minus 1 over 2 into 2 minus x to the power of negative 1 half. Alright, so this is it. This is 4x into the square root of 2 minus x. 2 cancels 2. Plus times minus is minus. X squared times minus 1, of course, minus x squared into this 2 minus x to the power of negative 1 over 2. So this gives 4x into the square root of 2 minus x minus, what this will produce is x squared all over, because of this minus, we can introduce a fraction. Then if I introduce a fraction, the minus disappears. 1 over 2 represents square root. So let me do LCM now. LCM is root 2 minus x. Divide this by this, you're going to get the same root 2 minus x times everything on top here. The law of sort says if I use root a to multiply root a, I'm going to get a, the number in the square root, as far as they are the same. So root 2 minus x times root 2 minus x is 2 minus x times the 4x, that will be 4x into 2 minus x. Divide this again by this, you're going to get 1. 1 times minus x squared is minus x squared. So what does this give? 4x times 2 is 8x. 4x times minus s is minus 4x squared and minus x squared. All divided by the square root of 2 minus x. Check. Minus 4x squared minus x squared is minus 5x squared. You will have 8x outside. All divided by the square root of 2 minus x. Okay. I think the answer, they factorize the numerator. What's common to these two? X. Bring the x outside. We have 8 minus 5x left divided by the square root of 2 minus x. And this is the derivative of this particular function with respect to x. It is needless. Okay, let me say that. It is needless to actually rationalize the denominator. Yes, most in calculus, we don't normally rationalize. It's just like that. So when you get a square root like that, you can leave it. Except if in the option in the exam, the examiner left the question in the form of a rationalized sort. You can do that. All right, let's perform the derivative. This is f of x equals x squared plus 3 all to the 4th power into 2x cubed minus 5 all to the power of 3. 2x cubed minus 5 raised to power 3. So what's going to be f prime of x, which is the dy dx. Now, there are two functions here. Okay, this is one of the functions, and this is the other function. Each of them is a function of a function. You get it? And in combination, it is a product. You get what I'm saying? So we actually deal with a mix of chain rule and product rule here. But the entire function itself requires the product rule for differentiation. But along the line, chain rule will be involved. You can pause the video and make an attempt to solve the question on your own, and then you play to see if you got the answer correctly. But let's do this one. Okay, let me say let u be x squared plus 3 raised to the 4th power. So what is going to be du at du dx? Using the chain rule is simple. This is 4. Okay, 4. The rule says write the 4. Differentiate this inner function, you're going to get 2x. Write the function again, x squared plus 3. Subtract 1 from the 4, that will be 3. So we are having 8x into x squared plus 3 raised to the power 3 as du dx. Then v is the other function, 2x cubed minus 5 raised to the power 3. So what's dv dx? Dv dx is simple. 3 is here, write it down. Differentiate this inner function. 3 times 2 is 6. 3 minus 1 is 2. So we have 6x squared. This one will give me 0. So into 6x squared. Then write the function itself again. That will be 2x cubed minus 5 raised to the power 2 now. You get it? So what will this give me? This is 18x squared into 2x cubed minus 5 all squared. So what's dy dx finally? Dy dx is simple. Using the product rule, v du dx, write this times this. That is 2x cubed minus 5 raised to the power 3 times 8x into x squared plus 3 cubed plus u dv dx. Write this times this. That will be x squared plus 3 to the 4th power times 18x squared into 2x cubed minus 5 to the 2nd power. Very easy. All right. So let's do this. 8s into this plus 18x squared into this 2x cubed minus 5 squared. Okay, is there anything we can do further? Yes, see something. S squared plus 3 is here, is also here. But this one has the power of 3, this one has the power of 4. 2s cubed minus 5 is here with a square, this one with a cube. So I want to bring out 2s cubed minus 5 raised to the power 2. Since it has a 3 here as a power, it has a 2 here. So I will try to bring out a lower power. Okay, by the way, check. S is here, S squared is here, right? So I can bring S. 2 can divide, what can divide 18 and 8? The highest number is 2. Bring the 2. So see what will be left inside the bracket. Okay, hold on. I've factored 2 here from this 2. Just follow me. I factored S here. So what will be remaining? Okay, before I write what's remaining, I said I'm going to bring out 2s cubed minus 5 raised to the power 2. You get it? 2s cubed minus 5 squared. Then for this one, I'll bring out s squared plus 3 cubed. This one has 4, this one has cube. So I should bring the lower power. S squared plus 3 cubed. Good. So I'll now write what is left in bracket. I brought out 2x here. So what will be remaining here? 4. I brought out 2s cubed minus 5 squared from here. So this one has power of 3, remaining power of 1. So I'm writing just 2s cubed minus 5, right, to the power of 1. Then I think I'm done with this. Okay, I brought out s squared plus 3 cubed, which is exactly what is here. So they will cancel out because they have the same powers. Then I'll just write what is left from the other side, plus I brought out 2s from 18s squared. What's remaining? The remaining 9x. So that 9x times 2x is 18x squared. I hope you get what I'm doing. Then I factored out 2x cubed minus 5 all to the power of 2. So nothing is left here like this now for this one, since they have the same square. Then for this one, I have s squared plus 3 cubed. I brought it out. Then I will having s squared plus 3 to the power of 1 left here. You get me? So this is s squared plus 3 raised to the power 1. Since it was raised to the power 3 outside, close it. Then let's see what's going to happen. This is 2x into, don't bother expanding all of this because there's no need. S squared plus 3 cubed into 4 times, I can expand this once now straight. 4 times 2s cubed is 8s cubed minus 20. You get it? 9x times s squared is plus 9x cubed. 9x times 3 is 27x. Check. I think I can handle these two together because they are like terms. 8 plus 9 is 17. Yes, 17. So this one will give me 17s cubed, right? So I should just write 17s cubed now. I can just write 17s cubed. You'll see 17s cubed minus 20. Okay, let me write it 27x before 20. Okay, look at it, 17s cubed plus 27x minus 20. 17s cubed plus 27x minus 20. And that's it. This is the final derivative. The derivative of this particular function, this one, with respect to x. Question 12 now. Y is equal to sin 3x plus cos 2x. What is the derivative of this function? Now, take note. The derivative of the sine function, sin x, is cos x. Differentiate sine to get cos. Differentiate cos to get minus sine. So I want to differentiate sine 3x now. So if I differentiate sine kx, the k will come out, okay? I'll be having k. Differentiate sine to get cos, I'll be cos kx. That's it. Then if I differentiate cos ks, the k is going to come out as well. Differentiate cos to get minus sine. So that will be minus k sine kx. It's quite easy. So differentiate sine 3x. It means that dy dx is 3 will come out. Differentiate sine to get what? Cos. Plus the 2 will come out. Differentiate cos to get what? Minus sign. Obviously, this one turns to a minus sign 2x. And that's the derivative of y equal to sine 3x plus cos 2x. Alright, how do we handle the derivative of tan x all squared? First of all, the derivative of tan x is sec squared x. Okay, so if I want to differentiate this now, this is actually a function of a function. Yes, because tan is a function that is trigonometric, x squared is algebraic. So there is an algebraic function inside a trigonometric function, which makes it a function of a function, and the chain rule will be applied. So what happens here is this. In simple terms, I want to use the rule. You know, chain rule says, let me move this question here, 14. Y equals cot 1 minus 2x squared. So I'll select u, the equal to x squared. You get me now? Then I'll differentiate u with respect to x, du dx. I'm going to get 2x. You know, if you differentiate x squared, you're going to get 2x. By the rule, we'll now say y is equal to tan u. Right? That's the chain rule now. I will now replace the x squared with u. So if I differentiate y with respect to x, differentiate tan to get sec squared. That's what I said just now. That's sec squared u. So the chain rule principle says the y dx equals the y du times the u dx. So what will this produce? It's simple. It's simple. The y du is sec squared u, the u dx is 2x, so we have 2x outside. So this is actually 2x times sec squared u. What is u? U is x squared, so we have sec squared x squared. This is the y ds. Okay, I think there should be a shortcut to this. Look at the shortcut. I have y equals tan x squared. The shortcut is this. The inner function is x squared. Differentiate it. Differentiate the inner function. You're going to get 2x. Then differentiate tan. If you differentiate tan, you get sec squared. Then write the x squared. You're going to get the same thing. Good. So if I want to apply the shortcut here, take note. If you differentiate cosec, which is written as CSC. If you differentiate cosec s, you are going to get minus cosec x cot x. Are you there? But if you differentiate cot x, you are going to get minus cosec squared. That's it. So if I want to solve this problem, using the chain rule, yeah. Question 14 now. Using the chain rule, I should be saying the y dx is this. Let me apply the shortcut. Yes. The inner function is 1 minus 2x squared. Differentiate it. Differentiate 1 to get 0. Of course, I'm differentiating with respect to x. Differentiate minus 2x squared to get minus 4x. You know that. Differentiate cot. If you differentiate cot, what are you going to get? You're going to get minus cosec squared. So this is times minus cosec. This is how we write cosec, CSC. Minus cosec squared. Then rewrite this function again. We're going to get 1 minus 2x squared. So minus times minus is a plus. We have 4s cosec squared 1 minus 2x squared. This is the divided s in using the short form of the chain rule shortcut. This is it. Now, for a function like y equals tan square x, take note. You know that tan squared x and tan x squared, they are not the same. They are not the same. But this is also the same thing as saying tan x all squared. Alright, so I'm still going to use the chain rule to solve this question. Look at the principle. I can do it. I think I can do this in two ways. Okay, see, look at the shortcut. What's here? This is 2, right? I want to show you the shortcut to doing this now. This is 2, write it 2. Then differentiate the one inside. If you differentiate on x, what will you get? You're going to get sec squared, right? So write the sec squared x. Then rewrite this one again. Then raised to the power 2, remove 1. It's like when we are doing the derivative of something like this, 3s minus 1 raised to the power 5. This is how we do it now. You know, you're going to write down the power, multiply by the derivative of inside, then you write the function again, take away 1 from the power. So this is it. This is 2 sec squared x tan x as the derivative. You can follow this process of using the chain rule, the chain rule formula directly. That is the dy du times du dx. You're going to set this one inside as the u. You're still going to get the same result. So what I did, this power, write it down, differentiate the tan x. Now, okay, differentiate the tan x, you're going to get what? Sec squared x. All right. Now, what you do next is simple. Write the function itself again, then subtract 1 from the power that was there originally. What if we had something like this? Okay, let me show you something. What if we had something like, what if the question was like this? What if the question was like this? I want to use this particular question to show you how the manipulation will look like using the chain rule. Yeah, it's very interesting working with the chain rule, but look at this. Let's say I have y, this question 16 now, y equals tan, let's say tan 5x minus 1, or let's say 5x squared minus 1. Then look at it. Okay, tan square 5s cubed minus 2. How do we differentiate this? It's easy. Yeah, I want you to understand the difference between these two particular shortcuts. So let me show you here. Let me strike the balance here. This is y equals tan 5x cubed minus 2. You know, I'm going to raise everything to the second power. That's what this means. That's what this particular square signifies here. So if I want to go by the shortcut, going by the shortcut, it's going to look like this. The y dx equals, the shortcut says write the power 2. Okay, that's 2. Then differentiate the inner function. Is that not so? But you see this inner function itself is a function of a function. The whole function as one question is a function of function. Inside a function of function, there is another function of a function. So I'm now performing two chain rule. That's the meaning. Inside I have tan 5x cubed minus 2. So how, if I want to differentiate this normally, what I will do is to say, write down, differentiate this one inside. 3 times 5 is 15, so I'll be getting 15x squared as the derivative of what is inside. You know, if I differentiate minus 2, if I go to x, I'm going to get 0. So differentiate this inner function to get this. Then I'll now say differentiate tan to get sec squared. I'll now write my sec squared and the 5s cubed minus 2. This will be the derivative of the one inside. So going by the rule, write it 2, differentiate this one inside, and that will give me everything here. So I'm going to write 15x squared sec squared 5x cubed minus 2. Then I will now say, rewrite this function again inside the bracket, which is tan 5s cubed minus 2 raised to the power of what? 2, remove 1. You know, that's what we did here. I wrote this one, differentiated the inner function, wrote it out. Then I wrote this one again, remove 1 from the power. So that's exactly the game that is being played here. So what's going to happen here is simple. This is 2 times 15, that's 30. 30x squared sec squared 5s cubed minus 2 into tan 5s cubed minus 2. If I raise everything to power 1, it's the same thing as this. So this is the derivative. Question 17. How do we differentiate y equal to cos x all over x? Still simplified. In this case, we are going to apply the quotient rule. You know, the quotient rule is, look at it, the YDS. I don't want to write the quotient rule, but let's follow from the rule. The top is always U, the bottom is always V. So the rule says, write V times differentiate U. If you differentiate cos, you're going to get minus sign. The rule has said write minus. Then write U, which is cos X. Differentiate the one under, which is V. And that will give me 1. Look at it. V du ds minus U dv ds all over V squared. This is X squared. So what would that give me? The y dx for question 17 is S times minus sine X is minus X sine X, then minus cos X. Look at this question 18. I want to differentiate the sine inverse of 3x. Watch me. I'll say, I want to eliminate the sine inverse. So I'm going to take the sine of both sides. Take the sine of both sides. It means that sine y is equal to sine of the sine inverse of 3x. So that when sine meets sine inverse, they cancel out. It means that sine y is equal to what? 3x. From here, I'll perform implicit differentiation. Alright, so see what I'm doing now. Differentiate sine y with respect to x. You are going to get cos y dy dx. See, if I differentiate 2x squared with respect to s, it's going to give me 4x. You know that 2 times 2 is 4. 2 minus 1 is 1. But actually, it is 4x ds. Anytime you differentiate a variable with respect to another variable, for example, I want to differentiate 2x squared with respect to p. I will be writing 2 times 2, 4, 4s ds dp. That's what I will write. This is the derivative of this function with respect to p. But do you know why ds will not appear? Because if I cancel ds, it's going to give me 1. So it should be remaining 4x. But the point is that dy cannot cancel ds, so it's going to stay. Take note. Now, differentiate 3x with respect to s, you're going to get 3. So look at it now. This is cos y equal to, cos y dy dx equal to 3. And from here, you make dy dx the subject of the formula. The steps are easy. From the question, take the sine of both sides. If it is cosine inverse, you take the cos of both sides. If it is tan inverse, you take the tangent of both sides. So any function you have there, take the inverse of that function itself. Then we have sine y equals this. Sine cancel sine inverse. We now have this resulting equation. Then you perform differentiation with respect to x in the next step. And from there, you make dy dx the subject of the formula. If I divide both sides by cos y, it will give me 3 over cos y. So this is my dy dx. But is this the answer? No, this is not the answer. Do you know why? I have to do away with the cos y. Now see something. Trigonometry says that, listen up, cos square x plus sine squared s equal to 1. It could be cos squared y plus sine squared y equal to 1. Any letter can be here, x, y, z, p, q, r, o, or whatever. So if I want to make cos s the subject of the formula from here, it means that cos squared s is equal to 1 minus this. And if I take the square root of both sides, it means that cos x is the square root of 1 minus sine squared x. Do you get me? It's very easy. Remember this identity always. From there, make whatever you have here, make it the subject of the formula. Then you are going to get something having the square root of 1 minus sine squared x. So since it is y, it's the same thing as saying cos y equals 1 minus sine squared y. Yeah, the same thing. Just variable change. So in place of this cos y, I want to write 3 over the square root of 1 minus sine squared y. Do you get me? 1 minus sine squared y. But do I know what sine squared y is? Yes, I do. This is sine y. Coming from here, this is sine y. If sine y is equal to 3x, the implication is that if I square both sides, I'm going to get sine squared y here. And if I square this side, I'll be getting 9x squared. You know that 3 squared is 9, x squared is x squared. So in place of sine squared y, I'll write what? 9x squared. That's the final thing. This means that dy dx is equal to 3 all over the square root of 1. Take away what sine squared y? 9x squared. And this is the dy dx of this particular sine inverse of 3x. I hope that is clear. I want to do another question, question 19. This time is for the cos inverse of the question I have there, 1 over 2x. All right, let me confirm that. Yes, cos inverse of 1 over 2x. Let's go with this now. I want to follow similar procedure, but maybe not 100%. It's simple, I'll say. If I take the cosine of both sides, okay, of course, from what we did here, I'll be getting cos y equals, cos we cancel cos inverse, like this. I'm having 1 over 2x left. 1 over 2x also means x over 2, so I should just write x over 2. Now, I have to differentiate. I will differentiate both sides now, implicitly. Differentiate sine, we got cos. Differentiate cos, you're going to get minus sine. That's it. Remember, differentiate cos to get minus sine. So if I differentiate cos y with respect to x, I will get minus sine y dy dx. So what is the derivative of x over 2 with respect to x? Look at it. I differentiated this side. I got this. I have to differentiate the other side now. The same way I differentiated 3x to get 3. This is x over 2. X over 2 also means 1 over 2x. So if I differentiate 1 over 2x, I'm going to get 1 over 2. You know that if I differentiate 2x, I'll get 2. Of course, with respect to x, I'll get 2. Differentiate 5x, I'll get 5, right? So if I differentiate 1 over 2x, it's not different from this. I'll get 1 over 2. So this will give me 1 over 2 at the other side. So I'm working with this. So what I will do now, from here, like what I did here, I made the y dx the subject of the formula. So let me do the same thing here. So from here, it means that the y dx is equal to 1 over 2. By the way, this minus will transfer. So give me minus 1. All over 2 is here. The sine y will still fall under this. Okay, it's very simple as it appears. Now, what we got here, we now made use of this formula, remember. From here, using the same identity, we're still going to make use of this one here. Cos squared x plus sine squared x equal to 1. So I now need for sine, no longer cos. It means that sine squared y will be equal to 1 minus this cos squared y. And if I take the square root of both sides, this square will leave. I'll be getting this. I hope you understand what is trying to happen here. It's just I'm just doing algebra, trigonometry, and calculus together. Yes. So in place of sine y, I'll write the square root of 1 minus cos squared y. 1 minus cos squared y. Okay, but check. This is cos y equals x over 2. It means that if I square this side, I'll get cos squared y. If I square x over 2, I'll get x squared over 4. Is that correct? Yes. So I should be writing x squared over 4. Let's take LCM now. This is minus 1 over 2 into the square root. This is over 1. LCM is 4. 4 divided by 1 is 4. 4 times 1 is 4. 4 divided by 4, 1 times x squared is x squared. So what happens? This is the square root of 4 minus x squared over 4. Both the numerator and denominator is being affected by the square root. But the square root of 4 is 2. So this is minus 1 over 2 into the square root. Okay, look at it. Into the square root of the numerator here, 4 minus s squared. Since the square root of 4 is 2, the 2 will come outside of that square root. I hope you get me. The 2 is no longer inside the square root since I took the square root of 4 and it gave me 2. But this 4 minus s squared will still remain in the square root because I didn't do anything to it. And you know that this 2 can cancel this 2. What that means is that I have negative 1 divided by the square root of 4 minus x squared. And that is the derivative of the cosine inverse of 1 over 2x. Look at this. Question 20. What is the derivative of the tan inverse of 3 divided by x? It's easy. It's easy. I believe you understand what I did in question 18 and question 19. So in question 20, see what's going to happen. If I take the tangent of both sides, I'll be getting tan y equals 3 over x. But 3 over x can be, okay, fine. Let's leave it like this first. Yes. Yeah, let's leave it like this. Let me take the derivative of both sides. Okay, to make it easy, I can write this like this. The tan inverse of, tan y equals 3x raised to the power minus 1. Yes, because this 1 over s can be written as s inverse. Okay, so from here now, I can differentiate both sides. Differentiate tan, you're going to get sec squared. And you know, if we do this, I'm differentiating tan y with respect to x. So I should write sec squared y dy dx equals, if I differentiate this, what will it give me? Minus 1 with times 3 to give me minus 3. And I have x to the power of minus 1 minus 1. Differentiation rule now. Minus 1 times 3 is minus 3. Then subtract 1 from the minus 1. And that gives you minus 1 minus 1, which is minus 2. So this is sec squared y dy dx equals negative 3x to the power of negative 2. True or false? Now we are trying to look for tan inverse, the derivative of tan inverse of 3 over x. So let's make dy dx the subject of the formula. It's going to be minus 3x minus 2 divided by this sec squared y. But do you know that in trigonometry, take note of this formula also. Sec squared y is equal to tan squared y plus 1. So based on this trigonometric identity, it means that sec squared y is, this is it, minus 3x to the power minus 2 divided by, in place of sec squared y now, I can write tan squared y plus 1. Tan squared y plus 1. We are C, dy dx is equal to, this one on top remains, but I'm going to do something later. What's tan squared y? Tan y originally is 3 over x, right? Or which is 3x to the power of minus 1. If I squared both sides, this will be tan squared. I have to square this also. 3 squared is 9. Okay, see, let me do it from here. 3 squared is 9. S squared is s squared. So I'll be getting 9 over x squared. 9 over x squared. Or let me just, anyone that suits you actually should work. 9, let me just write 9x to the power of minus 2. I'll manipulate it later, plus 1. And this will give me, what's on top? Minus 3x to the power of minus 2. So what's going to happen now? This is minus 3x. The numerator here has negative power for x, so I can write minus 3 over x squared. You agree? For the numerator, then this is divided by everything under. It is 9x to the power of minus 2, which I can write as 9 over x squared. You know that. Then the plus 1 is still there, plus 1. So let me simplify that. Anything I get from the simplification gives me the answer. Just stay tuned, keep watching. In a few steps, the derivative will come out. So we have this. minus 3, divide the x is minus 3 over x squared, divided by, let's do LCM here. This is x squared now, this is over 1. The LCM is x squared. X squared divided by x squared is 1. 1 times 9 is 9. X squared divided by 1 is still x squared, times 1 is what? X squared. So this is it. Minus 3 over x squared times the x squared goes up. This one comes down, 9 plus x squared. So what happens? This one cancels this. What's left? Minus 3 divided by 9 plus x squared. And this is 100% perfect. So can you try this? Y equals sine inverse of x minus 1. Maybe you should do this. Yeah, do it and drop your answer in the comment section. Let it be reviewed. What is the derivative of the sine inverse of x minus 1? Alright, let's call it a wrap for this video, this particular video. Alright, so I hope you enjoyed watching. Don't forget to subscribe, don't forget to like, and don't forget to share this video to your friends and to your classmates. I have a lot in mind to do for you guys concerning algebra, trigonometric calculus, mathematics, and so on. And I hope I'm able to do it. I hope I'm able to satisfy your needs as per maths courses. So stay tuned, keep following, subscribe, like, and share.